I welcome you to another series of our videos. So in this video, we will continue talking about vectors. So the question we have is coming from College Physics, Sewe, 11th edition, problem 68. So let's look at the question. The question reads, a map suggests that Atlanta is 730 miles in a direction 5.00 degrees north of east from Dallas. So we should take note of every detail or every information in this sentence. So we continue. The same map shows that Chicago is 560 miles in a direction 21.0 degrees west of north from Atlanta. So as I've mentioned earlier, take note of every detail. Figure P1.60 shows the location of these three cities. So this figure, we'll see it in the next slide. Modeling the Earth as flat, or in short, assuming or taking the Earth to be flat, use this information to find displacement from Dallas to Chicago. So they want us to find the displacement from Dallas to Chicago. So we have to understand what displacement is. Displacement, it's a vector quantity, so meaning it will have both the magnitude and the direction. So we have to find the magnitude of this displacement and also the direction of this displacement. So the direction, they simply talk of the angle. So let's look at the diagram. So Dallas is here, as it can be seen. Then Atlanta is here. Then Chicago is here. So they want the displacement from Dallas to Chicago, from here to Chicago here. So they want the displacement. So we have to understand that this here, the angle is 5, here the angle is 5 degrees. Then here the displacement, the angle is 21.0 degrees. So then these are the magnitude of the displacement, the magnitude of displacement. So it is important that for us to solve this question, we need to find the components of these vectors. So we have to resolve these vectors into their components. So we can take each vector, as if it was just one vector. So I'll show you what I mean in the next diagram. So this is right. So let's assume this vector is vector A. Then this vector is vector B. So in the next diagram now, so this is vector A, this is vector B. So if this is vector A, then we have to, we said that we need to find the components of this vector. So we have to find the x component and the y component. So the angle, it's 5 degrees. Then the magnitude of this vector is 730 miles. Then this vector B, the magnitude is 560 miles. Then the angle, this angle here, it's 21 degrees, but we say that whenever you're dealing with vectors, we should always be making, or it's easy to solve vectors when you make the positive x-axis, as your reference point. So when we make the positive x-axis as the reference point, it will mean that this here, it's giving us 90 degrees angle. So plus 21, it will give us 111 degrees. So it will mean that from here, like this angle, it will be 111 degrees. So that's if we make the positive x-axis as our reference point. So we can continue now to resolve these vectors into their components. So we'll start with resolving vector A into its component. So let's start. So to resolve vector A into its component, we are given the formula. To find the x component, we use this formula. X is equal to A cos theta. So A is the magnitude, which is the magnitude of A, which is 730 miles. Then theta is the angle, which is the direction. In this case, it was 5 degrees. So when you use a calculator, when you punch on a calculator, you find that the x component is 727.2221296 miles. So therefore, the x component of vector A is 727. So we find the y component of vector A. So to find the y component of vector A, you use the formula y is equal to A sine theta. What is A? A is the magnitude of vector A, which is 730. Then theta is the angle. In this case, it's 5 degrees. So when we punch this on a calculator, it's giving us the y component to be 63.6236921 miles. So this can be written to three significant figures as 63.6 miles. So in physics, you are always advised to write your answers in significant figures. So usually we write them in three significant figures. So that's the y component of vector A. So let's also resolve vector B into its components. So to find the x component of vector B, we will use this formula. X is equal to B cos theta. The B here is the magnitude of vector B, which is 560 miles. Then the theta here, we will use 111, as we have explained earlier, that we will use 111 because we are considering the x-axis, the positive x-axis, as our reference point. So when we punch this on a calculator, we will get the x-axis to be negative 200.6860517 miles. So that will be the x-axis of vector B. So we can write this in as negative 200.7 miles, like this is in four significant figures. So to find the y component, you use this formula. Y is equal to B sine theta. B is the magnitude of the vector B, which is 560. Then theta is the angle, which is 111 degrees. So when we punch this on a calculator, it will give us 522.8050388 mouse. So we can write this in 4 significant figures as 522.8 mouse. So this becomes the y component of vector B. Then this is the x component of vector B. So at this point, we can say that we have resolved these vectors into their components. So the next thing to do is to do the summation of these vectors. Like the components of these vectors, you sum them. The x components, you sum them. The y components, you sum them together. So this is easily done in a table format to avoid making mistakes or errors. So this is vector column, components. So x component, y component, all these are in mouse. So vector A, the x component is 727.0. Vector B, vector AY component is 63.6. Then vector B, the x component is negative 200.7. Then the y component is 522.8. All these are in mouse. Then when you do the summation here, you get 526.3 mouse. So this is the resultant. Then when you also do a summation here, you get 586.4 mouse. So we can tell that the x component of the resultant vector is positive and the y component of the resultant vector is also positive. So we can tell how this resultant vector is looking like. So it's looking like this. This is the x component, this is the y component. So we can tell that this is in first quadrant. So this information will be helpful in finding the direction. So this is how this is what the resultant vector is looking like. This is the x component, this is the y component, then this is the angle. So let's now find the magnitude. So to find the magnitude of this resultant vector, we'll use this equation, which is equal to the square root of x squared plus y squared. So we replace, where there's x, we replace with this 526.3, then we even square it, then plus, where there's y, we replace with 586.4, then we square it. So when we punch this on a calculator, we'll get this. So we'll get the square root of 620,856.65. So when we use a calculator to find the square root of that, we find that the magnitude of this vector is 787.9445729 mouse. So it's also important that you take note of the units. So we can write this in 4 significant figures to be 787.9 mouse. So this is the magnitude of the resultant vector. Let's also look at the direction of the resultant vector. So to find the direction of the resultant vector, you use this equation. Theta is equal to tan inverse y over x. So these are just components of the resultant vector. So you replace the y component, the y with 586.4 because it is the component, the y component we found from our calculation. Then where there is x, you replace with 526.3 because that's the x component we found from our calculations. So when you use a calculator here, you find that it's giving us 1.1 1419. Then when you use a calculator to find tan inverse 1.11419, you will find that the theta is 48.09 degrees. So this is the direction of the vector. So this becomes the answer because we realize that this vector is in the first quadrant. So this becomes our answer. So this is the direction. So the summary: 787.9 miles at 48.09 degrees from the positive x-axis. So this is the magnitude and this is the direction of the, so this is the displacement they wanted. So at this point we are done answering the questions. Thank you for watching. Remember to subscribe to our YouTube channel.